MAP4C 5.6, selecting a regression model for data. So previously we have looked at linear relations, quadratic relations, and exponential relations in the form of a table of values, in a graph, as well as in an equation. And what we're doing in this lesson is being challenged to be able to identify the type of relation in various formats. So let's start off with an overview of a table of values. How can we identify a relation in a table of values? Linear relations can be determined if the first differences are constant. So in this case here, we see that the first differences are not constant, so therefore it's not linear. A quadratic relation is determined if the second differences are constant. In this case, we see that we do not have equal second differences, so it's not quadratic. And ratios. Decay factors are constant. So in this case here, when the ratio, so we take 7 divided by 9, 5.2 divided by 7, here to get the decay factors. Now this is approximately equal to 0.8 for each. So this would be an exponential model. Now in the real world with scatter plots, oftentimes the data values are not fitting the model perfectly or exactly. But if it is pretty close, then we can do something called regression, which is modeling statistical data using some type of curve. It's best suited with an exponential model. Let's investigate graphs. Linear graphs are lines. Quadratic relations have a U-shaped symmetrical curve called a parabola. And with exponential relations, we have a curve, which is increasing exponential growth or decreasing exponential decay. To be able to tell between quadratic relations and exponential graphs, notice that a quadratic relation is symmetrical, where an exponential graph approaches a value but does not cross. We call that a horizontal asymptote. In an equation, linear relations are of the form y is equal to mx plus b. You can see that this is the slope m and b is the y-intercept. A stronger definition would be that it is a degree 1 polynomial, meaning that the power on x is 1. If nothing is written, it's assumed to be 1. Notice this is in the form y is equal to mx plus b. Next, quadratic relations. We've seen various forms such as standard, factored, and vertex form. So it has different forms, but the characteristic that is most easily identified is that it is a degree 2 polynomial, meaning that the exponent is 2 on x, or the greatest power on x is 2. Exponential relations are of the form y is equal to ab to the power x. Notice that the exponent is the variable. If we have an actual exponential relation with numbers substituted in this case the initial value is 1000 and the base is 2. Notice that the exponent is a variable, and that's the characteristic that makes it an exponential relation. So try questions 1 to 6 and test your understanding.